Hi, what's going on, guys? So today we are going to do another issue, right? So we are still in assembly workbench, and we are going to work on another problem, right? So the problem, the, so this problem, it has actually a lot of issues. So in assembly, when you ground an object, it adds this small lock pad here, this icon. But this is actually not an icon. So if you ground something, let's say you ground this, first let's activate the assembly. Let's say we ground this, for example, it will add a lock pad here, and if you unlock, it removes the lock. And the issue is that this is actually not an icon, it is actually the label itself. So if you click and you do rename, you see the lockpad is a Unicode character directly in the label of the string, and so this has a lot of problems. So for example, if you rename it, so if you remove it, or maybe you rename it something like this, or well, so yeah, so there is already 3 or 4 issues in the tracker because of this. So we need to change that, right? We cannot keep that like it is. So so then the question is, how do we make it clear that this object is grounded, right? One possibility would be to put, let me show you in the issue. I made the mockup, the icon, lockpad icon, on top of the icon of the object. But to do this, you have to modify the cube object so that its view provider shows like the icon like this, right? Because in this situation, I was actually changing, in current situation, I was actually changing the cube object by changing its label, right? And so here it's the same, and we have to change the cube object, and so it's it's a bit difficult. So then we thought about another possibility, and it is to actually show something in the view, right? So if you, the same way as the joints, you see the joints objects, they have a representation on the 3D window, like on the 3D view. And so for the ground object, it could be the same. Currently, the ground object, it has no visibility because it has nothing, right? So yeah, so we are going to do this. That's funny. Why is it the dragger is appearing when you select the grounded object? So we found another issue to solve, right? But first, let us focus on this. So we want to have like a visual representation for the grounded object. So let's start with this. So we are going to the join object.py, which is where the join object of assembly is defined. So this is in Python, this part of the workbench. And so this this joint, it has like an object class and a view provider, which are actually proxy classes for the feature Python object, right? And so for the grounded joint, it's the same, right? We have grounded joint and then a view provider grounded joint. So if we want to have something in the 3D view that appears, we have to add something with the attach function. So currently it's empty, and we can take the view provider joint as an example. So if you look at here, we have a lot of bunch of code, and so if we copy paste this, basically the grounded joint will look the same as the GCS, the joint connector system. So it's not exactly what we want to do, right? So we want to change that, and But so the way we are going to do it is by re-implementing something similar to this. So maybe we can start by copy-pasting it. Copy-pasting it here. Let's see. Or maybe even better, you know what? You know what we are going to do? We are going to take advantage of ChatGPT. That's going to be awesome. Let's we are going to give it this, and also callback, camera callback, because that's to scale the icon, and then GCS separator, line separator. These are actually subclasses, right? Functions that are called by the attach functions. So we'll also take them, and then we have get. Maybe you can just take everything, right? Get GCS, get icon. Well, we don't need everything, but I think get size is probably useful. Well, let's just take everything, but not the last ones. It's useless. Get icon is useless. Unchanged. Yeah, unchanged. We are going to take it. Get default display mode. Yeah, that's small stuff, right? Set pickable state. Right. So we are going to remove some stuff, right? I don't know. Let's just. Oh yeah, we don't need that. Unchanged. Yeah, let's take everything like this. We're going to take this. ChatGPT is quite a powerful tool when you need to do something like this. You want to adapt a whole paragraph of text. So that's can be. So let's tell him I have joined to object in Python FreeCAD. This object has representation in the 3D view. It is drawing two coordinate systems. Here is the code for it, right? Let's give it the code here, and I also have a grounded joint object, and this object has currently no visual in the 3D view. I want to change that. And what is cool is that we can even tell him that we want to draw a lockpad symbol, and I think it might just give us like something that actually looks like a lockpad, but we'll see if it can provide, you know. So let's give it this. So please help me modify the attach function so that the object has a lockpad representation on the 3D view. Please help me modify the attach function so that the object has a answer, and we can give it a color red. Well, let's not ask him too much right now, right? We're going to see what happens. It may be too big of a task because it's quite a lot of text. I don't know if it's going to succeed, but let's see if it can. Meanwhile, we'll have a look at for the color, because for the color it appears that view parameters. Oh yeah, that's fine. The axis. So we are going to do the same for the color of the lock symbol, and we are going to use red as a default for now, because it's the same color as constraints in assembly, in Sketcher. Sorry. So well, let's see what it gave us. Well, that looks like a good start. So create a cube for the lock pad representation. Okay, so that's not so great, but I mean, with the amount of text it can produce, it's not so surprising, right? So we are still going to use that because there is this red color. Yeah, there's not much we can use. I mean, he's using a cube for the lock pad symbol, so that's... Actually, we could use a cube with a torus. Oh, that's nice, a cube and a torus. We use a cube, well, not a cube, like a rectangle, and then with a torus for the... So that would make a lock pad, so we don't have to do it in 2D, I guess. But where is the... Oh yeah, the transform is here, okay. Well, at least it gave us an interesting idea. Lock pad separator. So separator in there. Lock pad shape. Lock pad color. Well, anyway, let's start with this and we'll see what we do. Command, view provider, joint. So that's... so we are going to take the color from the self lock pad color. We don't really need to store that anyway. So, oh yeah, wait. Oh yeah. Okay, we need that as well. Yeah, so we are going to use lock pad color, and then something like this. We have to first take the color as an integer, unsigned integer, and then we can say like constraint assembly constraints. I don't know why I'm actually using view parameters. We are going to use rather app param get. Oh yeah, so we are going to store this color in the assembly preferences. So preferences.preference get bool. Yeah, we can do it like this, but yeah, assembly constraint. So this will store. This is returning the parameter group of assembly workbench, right? So we are going to store that in in there. Okay, and so then we just need to do something like set value, and we're going to use what is that? Oh wait, color from unsigned. Oh yeah, okay, so first the color, we have the color, then create the transform. Yeah, we're going to need the transform, and then let us start small, right? So we are going to attach the scene graph to the view provider, add display mode. Well, if it's calling the display mode like this, because the joint object for the joint object I've been leaving the wireframe, which is basically the default. So let's also put the default. And then we have like the GCS, we have peak, which is the peak style. We probably, no, we don't need that. We have GCS, and the GCS it has like a transform. And the source scale, yeah, this is what I'm looking for, the axis scale. So it's added somewhere inside this function, deeper inside the functions. So because we are going to need to have like something that scales the cube, because we don't want it to be so big. So first, if we do it like this, let's see, if I just save like this, I think we'll have a cube that appears, right? Let's try that first, up, and see what happens. I think that will just make a cube at the center of the document, because the transform has no... Okay, something is wrong. Object, blah blah blah, no attribute, lockpad color, 812. So 812. Yeah, okay, that's fair. Yeah, so let's int, let's call that int. Okay, so let's see what happens. So it should create a cube of 10 by 10 by 10, right? Let's see. First we close this. This is still recording, great. And so assembly, and then we select fix. We are going to fix that, and we have to see if a cube appears somewhere. No. Yeah, Python is very annoying for that. It will let you write anything, but then it doesn't work, because at least in C++ you see directly when something is wrong. So this is wrong. So why are you doing that to me? Yeah, at least in C++ you know directly that it's not, the syntax is not correct, right? So let's see, where is my cube? Oh, it's already there, look at that. Red cube. So that's logical. It's 10 by 10 by 10. It's in origin point, because we didn't give it any transform, like we didn't told it where it should be, and it even has the well, that's not so good. Why is it still having that? Well, anyway, so so this cube, we want it to appear right on the part. So first, let's see if it disappears if I hide this. Yeah, great. So it is good. So first, we need several things. First, it doesn't look like a lockpad, right? So that's going to be a problem. Second, the second thing is that it's not at the correct position, so it has to be at the center of the object. It's not scaling with zoom. What we want is that it scales with the zoom level, so it's always the same size, which is not here, right? If you zoom in, it becomes very big and very small. And then And then we have to fix some problems, like it should not be selectable. So let's go. So I don't remember how we were using the scale in the joint object. So in the joint object, yeah, scale is here. Scale, get GCS size. So get GCS size, camera. Yeah, so we need something like that, right? So get GCS size. We need the same function. Maybe we could even reuse that. Camera height and else 10. Well, the thing is that, yeah, never mind. Let's just add something like this, alright? We're going to add it. Get log size. So it's basically the same. We'll even try the same values for now. And if the same value works, then I guess we can just make one external function. Maybe we can even do it now, right? Because or at least we can have like all of this, like the return, and yeah. So get camera, we can have something like get camera height, or yeah, we are going to add a function. So here, for example, get camera, get camera height, something like this, and this will return. Let's have it return that. Wait, what? Wait a moment, this is wrong. Yeah, this should be gone. Okay, and so by default we want it to be 10, so that means that's 200 by default, right? Because if I divide it by 20, it will give 10. So in joint, we are going to do get camera height. Wait, height is written like that, right? I'm not sure actually, but sounds like a mistake I would do a lot of time. No, it's H then T, right? So I was initially right. Hey, get camera height. Well, we just return that divided by 20, I guess, like this. And so all of that's gone. Okay. And so here it's the same. We just return. Well, let's return that, and we'll modify this value if we need it bigger or smaller. Something. So get GCS size, so we are going to have like a scale, axis scale. Well, we'll call it something else, but basically it's, and the draw style well, the draw style, we don't need it because we're making a solid, so I guess it's fine. Let's just add like size, something like this. Or let's call maybe that factor. It's and this should be factor, right? It's not really a size. Get log factor. Yeah. Anyway, so where is it? It's here. Get log factor. Okay, axis scale, we can change this. We can just call it scale. Or maybe so scale. So scale. And so scale, we probably want it to be I don't know, can we put it directly in here in the so separator? I think we can. Well, if I call that yeah, let's be consistent a little bit. So if we do it like this, then it's probably going to scale. I'm not sure. Transform probably has to be there. Well, there's only one way to know, right? So let's first, so because here we are not updating based on camera, so we have to have like camera callback. Yeah, so this is why I'm adding the camera callback. Camera sensor, camera height. Okay, so we need the same thing as here, and yeah, let's put that here. So we need the same thing here, and we also need the camera callback function. Yeah, and it's going to do the scaling. It's going to do the scaling for us, right? Camera callback self get log factor. Axis scale dot scale factor is that? Yeah, it's correct. So it's just here. It's just scale, and we call that factor. Okay, so now let's try it and see if the cube is scaling correctly. This we can close. This is okay, the new window. Missing one required positional argument. Get camera height. Get camera height. Missing one required. Oh, okay, I didn't remove the self. Great. Let me check if you're still there. Oh, yes, you are. Okay, that works. You see the cube, it's always the same size, whatever the zoom level is, right? So it's slightly too big, very slightly. So we want that maybe 10 times smaller. Yeah. Yeah, at least 10 times smaller. So one way to do it is to just do this. Let's see. That's much better. Maybe even a little bit much. Maybe still a little bit too much. If let's see, maybe let's make it 300. So let's start to make it look like a cube, right? So a log pad, I mean. So a log pad, it looks basically, I don't know, it's squarish, and then we have one side which is only maybe 3, maybe even 2. Let's try 3. See if it looks better. Yeah, that's the the only one. Fine, and it's a bit small now. Yeah, no, it's fine, I guess. Yeah, it's fine, but it's just not the correct. Let's maybe the width, I don't know. Okay, and now we want to transform it to the correct position. And so for the GCS, how is that done? We have to change the sort transform, and which is basically kind of the same. Here we have like the transform one, which is given to this function, and in this function, yes, it's just added here. But then where is so transform one used? Transform 1, transform 2, let's see, user data, if placement change. Okay, if placement change, then we do set GCS placement, and that's the only place, right? So we are going to do the same. So if the placement, because the grounded joint also has where was it in update data? So in update data, we are going to do the same. So if prop equals placement, I think it's called placement, the property, we'll check that later. Then we can change the name here, joint. Let's call that joint here, because it's more joint than so if object 2, it has like object to ground, I think it's object to ground. PLC equals joint dot placement. So switch all. What is that? Yeah, let's remove that. I think that can go as well. Self set GCS placement. Ah, it's pouring outside. It was sunny maybe 10 minutes ago. Let me just get some more light. That's not much, but it's enough. Oh, that's some real rain. So set GCS placement is a function here, yes, and it takes the transform, the placement, blah blah blah. Let's just take that, and we are going to paste that in a camera callback. Where here? Maybe let's try to at least keep like the order. So first this, then set placement, and then so before update data. Well, that's good, but that's this one which is not at the correct position. It's not so important, but I prefer to keep things in the same order. It makes it easier to find things after. Okay, so we have to customize that. If property and and so we check that it has like an object. PLC equal that joint dot placement. I don't think that's correct. Well, I think we don't even care. Well, let's first set, we are going to change that, set log placement, set log placement. The sort transform, we don't need it because we only have like one transform, so we're just going to remove this here. Where is it? Here, set, so we are replaced like this. So we still have one placement, we still have object name, why are we doing that? And here we have the object placement equals global placement of the object multiplied by the placement. Okay, so because the GCS in the joint object, the placement is so the placement of the GCS in the join object is relative to the object origin, not the document origin. But in our case, we actually don't want, like, all of that, we don't care, right? Because it's already relative to t equals placement base, self transform translation, set value t.x, t.y. So that's correct. And then set rotation, blah 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 blah. So that should all be correct, but not this. Joint. Let's call it G joint to avoid any confusion. So this we can remove. We only have the placement now, right? And the placement. Okay, so now if we build, I think that it's going to be at the correct position. Let's see. Where is it? Oh, it is, but it is invisible. Look at that. I can see a tiny bit here. So if I select this one, let's try to make another one. See, let's make this one. Okay, so it's using, so the first problem that I'm seeing here is that it's using the origin of the part, and we want the center of the part. And the second one is that it is not like drawn on top of it. So two small issues. So first we want it to be drawn on top, and for that I think we can just change to so annotation, and that will make it on top, I think. And then so for the placement, we don't actually just want the placement. Let's see. We want the center of the bounding box. So we have a function in utils assembly which is giving us bounding box center, the center of the bounding box, but actually I think we don't really need this function. We can just use, oh wait, no, that's fine. View object, so we are object.view object. So instead placement, we're not going to use this, we are going to use gjoint.view object.get bounding box center. And this is not a placement. This is just a vector, right? It does not have. So first we have to do PLC equals equals, and we are going to use app.placement to make a copy of this object placement, right? So we have the same rotation as the object. And then we change the base of the base is the position in the placement, and you also have rotation, right? The placement is both a position and a rotation, and in Python the base is the position. So we do like this, and let's build again, see what happens now. Well, I'm saying build, but when you do Control B, it doesn't really build, it just copies the Python file to where they are needed. So we have a cube and the position is wrong, right? It's not correct, and yeah, it's at the origin of the, so it's at the origin. Why is it at the origin? Let's try something. No, not that. Let's try to ground this part. Yeah, so they all go to the origin, right? So that's, how could we make a step backward? Like, it was working fine and now we messed things up. App document object has no attribute placement. Well, I think it's when I tried to ground the origin. Let's see. Yeah. So we have to prevent that. That's another issue to fix, I guess. The grounded joint has to filter while it can ground. Okay, so how could we go back? Like, how is it not working anymore? When I was doing, let's see, if a property, what have I changed that is so bad? G-joint dot placement. No! Wait a moment. Oh, right, because it's object to ground dot this, and here maybe we want the placement of the object, right? Maybe it's better, I think. Let's see. Now it should be better. Ah, that's still not good. What am I doing? I must be doing something stupid right now. Let's check if... Oh, look at that. Here it's at the correct position. It's at the correct position. Yeah. It's at the correct position, and you can select it. That's... Why are you showing me the dragger? Come on, stop doing that. Oh, great, look at that. It is actually changing the position of the grounded joint. Look at, if I click on solve, then it moves. Isn't that fantastic? Alright. Oh, I can even drag it? No way. Okay, I can even click and drag it. So that's wrong in so many levels. It's the same, you know, when I click on something in assembly, then I think I crashed. No. When you click on something in assembly, you can drag it, and this cube you can drag it. Even if it's grounded, no problem. Oh wait, of course you can move it because you're changing the placement of the grounding, so actually it actually moves. So anyway, we still have the problem that this joint is not like, oh, it's at the correct position now. Okay, let's see, what can we do? What else can we do? Maybe we can improve our look a little bit. So we are going to add a torus. That's going to be tricky. Oh. Well, maybe ChatGPT can do it for us. Let's see. I want to improve the rendering of my lock pad because currently it's just a cube. Yeah. Can you help me? I want to add a torus. There is. So yes, instead of having, I think the lock pad in 3D is going to look weird. So instead we are going to draw it in 2D, and you know, with just in 2D and just transforming so that it always faces the camera. I think that's going to look better. It's more like what the SketchUp does, for example. So let's ask ChatGPT if he gives us a good start. Can you help? Here's my code. It works not too bad. I want to improve the rendering of my log pad because currently it's just a cube. Can you help me? I want to. So instead of drawing in 3D, I just want to draw the symbol in 2D. So basically a square, and how is that called, like if you have two arcs, you know? Okay, let's see if what it gives us, and then we are going to start to think about how to actually like camera callback. So the camera callback, I can use the camera callback to you know, change the self transform so that the rotation is actually facing us, right? Set lock placement. So basically we want to change set lock placement. Where is it changing? Oh yes, if we change, okay, set, and we are setting it to PLC. So set lock placement. So actually we want to change that, right? So we are going to have set lock position, and it's just going to take a position. let's call that pose, so that we can just use like pose here, right? Set lock position, and the rotation is going to be handled by something else. So here we want to put the base only. Okay, so that makes sense. So wait, we are going to check. No, it's the only place that this appears, so it's okay. Okay, so we're setting only the base, and the rotation is going to be given, is going to be calculated here, using the camera. So let's move that here to start. R equal placement dot. So the question is how we are getting the placement, I guess. Okay. So first for this is fine. This is fine. Lock position. This we can close. So let us think a little bit. So camera callback, when the camera is we want to get like we want to get the rotation so that it is facing us. And how are we going to get that? Camera equals, let's go in FreeCAD and try it directly. So let's do C. So this is a camera, and here adjust camera. Let's have a look at if we find like the rotation. Is there something like rotation? No. What we want is actually like the rotation of the focal plane, I guess. So of course it's going to be annoying. It cannot just be simple. Yeah, that's going to make a very boring video if well, never mind. Okay, well, first let's have a look at let's see. Okay, so for now we are going to comment that out because it's going to fail. To comment that out, and we are going to see if first we can you know, use like the 2D drawing, assemble the parts into a scene graph. Yeah, that's probably going to be that's going. I think we can guess that this is going to be wrong somehow, but it actually looks okay, I guess. So let's try to get that. Let's just try to get all of that. Honestly, I don't know how that can not go wrong, you know. Creating square arcs, assemble parts into a scene graph. So first we are not using, it's not using the transform. Oh yes, it's here. Okay, so we are going to put that here like this, and basically we are losing. So this is the lock, this is just the cube, so we can already remove it. And then the scale, we are losing the scale, so we are going to put that here. No, not here, we're going to put it here. Scale, and then the transform, and the lock path color. And yeah, it's using a separator. It's like everything that is wrong. I think the color, why is it not just putting the color in this annotation? Maybe it's not working. We'll try, okay, see what happens. Because I think it should be okay. Okay, so separator, square vertices, square face. That looks promising. I don't know if it's promising, but at least we can try it, right, and see what happens. Let's just make these so annotation just in case, because we want to be drawing that on top. Why is it putting the color? Let's try to remove the color from here as we are adding it here. Start angle, end angle. Oh, there is just so many ways it can blow up, but let us try. I mean, let us try and see what happens. Well, there you go. Set value. Well, that's already something. Well, let's see how long it's been. I think, yeah, almost 1 hour, so we'll stop here and start in another part, right?